Once you have the data prepared and ready to go, then k nearest neighbor is what is called memory-based reasoning node, or MBR. That's what SAS calls it. So bring in MBR, connect. And there are a couple of things that we have to set here. Okay. And we can check the variables. Okay, if you go right click and edit variables, then you will see the 19 principal components or the input variables, and then the churn is your target variable. Okay, so that's good. Now there are two methods that MBR node allows for the k nearest neighbor. Scan is what we've been discussing so far. Scan means every observation is now you're going to compute the distance for all the validate set. I mean, every observation from the validate set, then you will compute the distance in the training set for all of them, and then keep going like that, one validation observation after another. Okay. So and then you'll use k equal to whatever, and then decide on that basis. Okay. Now sometimes this can be really very inefficient in the sense that it may take a long time. Okay. And to hurry things up, you could use RD tree. So RD tree uses clustering method where the data set is grouped into several groups, and then it uses the distance between the cluster and the observation to figure out what the closest values are, and there is a procedure defined for that, and then you can set the parameters for RD tree. So RD tree is more efficient, but it could miss the real short as a closest observation, the nearest ones it could miss. So you're giving up a little bit of accuracy for the sake of efficiency. So we will set this to scan. Now scan is the regular. It goes through the entire data set. And the number of neighbors here, okay, now default is 16. Now what should the number be? Okay, so that's again something that we have to look into. So let's say start with 3. Suppose we want to set k equal to 3. Okay, set k equal to 3, and then you run. Okay. Now take a look at the results. So here you have the regular cumulative lift chart and so on, and here is our output where we have the train and validate set information and misclassification rate, 7% for train, 11% for validation. Okay, and then we have the root mean square, and here are the classification matrix, the confusion matrix data that you need. So that's given here, and it's repeated here. It's the same information given in a different format. What you see here is what this is. Okay. This is more direct. So you have the false negative, true negative, false positive, true positive for training set, and then the validation set. Okay. Now we will look at this more closely in just a minute.